Oh yes, the dimmer switch. Now we're going to work on a complicated circuit that uses variable resistors. Okay, these are resistors that can change their resistance. So how can we build a circuit in order to create a slowly dimming light switch? Okay, like you would have at home. All right, it's not that complicated. All we're doing is we're going to be taking a circuit that has a battery in it. Okay, imagine this is a power source. And we're applying basically like a series circuit, and we're going to be changing the resistance of half of that circuit. And if I change the resistance, I'm going to change the ratio, and I can then adjust the voltage coming out of one of those resistors. That's basically the principle that we're going to be looking at. So we have two different types of circuits that can make that. You have one that includes a type of switching resistance resistor called a variable resistor, and you have a special circuit that has a slider in it that is called a potential divider. And they look like this. Here, your variable resistors you would have as a dial at home that could then change the resistance of a resistor in a series circuit. Or you would have something like this where you have one complete resistor. Here's just a coil of wire. So it's one complete resistor in the circuit, but I have a slider on top that basically splits that resistor into two resistors. Okay, and I can change the resistance of one of the resistors in here. So that little arrow represents a slider that can move up and down that coil of wire. All right, so we're going to take a look at both of these and try to figure out how we can draw them and how we can do calculations with it. But in order to do potential dividing circuits, we first have to do a revision problem to take a look at two resistors in series and see how we can calculate the voltage or the potential difference across one of them. So remember, a little trick I showed you in class is that you can calculate the total resistance in a series circuit, and then the potential across one of those resistors is going to be related to the fraction of the total resistance. What fraction does that resistor have of the total resistance? Okay, once I find that fraction, I can multiply by the original voltage, and I can get the potential difference across that resistor. So for example, 24 volts times 100 divided by 300 ohms, because this is a series circuit, so that's 1/3. 1/3 times 24, the potential difference across here will be 8 volts. Okay, so then if I change that resistance and I change that ratio, I can change the voltage that is happening over here. Okay, and that's exactly how a variable resistor works. Okay, here's a 10 kilo ohm resistor, and I can change the amount of resistance that is in that resistor by switching this dial. And effectively what that's doing is changing the length of wire inside of that resistor. Remember, the length is directly proportional to the resistance. So if I change the length, I will change the resistance. Okay, so if I started with, let's say, 10 ohms, okay, on that lowest setting, okay, where would the bulk of the voltage be? Well, the bulk of the voltage would be over here. So if I wanted to find out how much 10 ohms, if I had my resistor set on the lowest setting, what would the voltmeter say? Well, let's just change the color here to something you can see. The voltmeter would say 24 volts times 10 ohms over 210. Okay, 210, because 200 plus 10 would be 210. That would be a very, very small fraction. Okay, so if I do that on my calculator right now, let's quickly do this. 10 divided by 210 times 24 would give me a total of 1.1 volts. Okay, so I'd have very small voltage coming out of here, and that voltage might not be enough to light up a light bulb. Okay, but then as I gradually increase the resistance, okay, by moving that dial to the right, if I increase the resistance all the way to the end, where it's 10,000 ohms, what would that voltage be? Well, then the voltage now at 10,000 is going to be 24 volts times 10,000 ohms divided by 10,200 ohms. And if I do that calculation, we will see that 10,000 divided by 10,200 times 24 gives me a total voltage of 23.5 volts. Okay, so then 23.5 volts will be here, and only 0.5 volts will be there. So as I move that dial and increase the fractional resistance, I will increase the voltage going to whatever is over here. So instead of a voltmeter, I can put a light bulb. Okay, that's the symbol for a light bulb. Okay, and as I increase that resistance of my resistor, now this is a parallel circuit, so it's a little bit more complicated, but if I increase that resistance, I'm going to increase the total resistance of that parallel branch, and I'll increase the fractional resistance of that parallel branch, and then whatever the voltage is going across here is going to be the same as the voltage going across there. So as I increase my resistance, I'm going to increase the voltage going across that lamp, and I will make that lamp brighter. Okay, that's how that dial, that little dial of a variable resistor works. Now the other type of variable switch where I can change the light, it works through a potential divider. So instead of having a series circuit like this with a fixed resistor and my little dial, here I just have one component, a slider. Okay, and what I would end up doing is I have a voltmeter here, but I can also do the same thing. I can have a lamp over here, and as I move that slider across, right now that slider is over here, okay, and if I had a battery attached like this, here, how would we have that battery? If I had a battery like this, just imagine that, then my potential difference is going across that entire resistor like that, okay? And if I also had a wire attached here, oh, I can't do that. That would make a parallel circuit. But yeah, if I had my wires attached like this, I have that as my complete resistor, okay? I have potential difference across that resistor, all right? And then as I slide this slider, I can create a different circuit, okay, that's attached, not a different circuit, but a different resistor attached inside of that circuit, okay, such that I'll be creating, here, whoops, I should turn this green, okay, such that I would be creating something that would look just like we had up top. So if I wire this up properly, okay, and as I slide that slider over, I can change the resistance of one of these components, okay, and I can create, I'm basically splitting that coil of wire, which is one big resistor, into two resistors, okay, and my lamp would be attached in parallel to one of these resistors, okay. So as I move that dial over to the right, all the way. If I moved it all the way, now basically what I've done is created two resistors, like basically have just created a lamp over top of the other resistor. So the entire potential difference is going to be the same over the lamp as that. But if I move it over to half, okay, then I will take that total resistance of that resistor and I'll divide it into half, okay? So let's imagine the total resistance of this resistor was like 100 ohms. If I moved that dial halfway, I would create two resistors that are 50 ohms, okay? If I would move it a third of the way, I would create a resistor here that would be a third of the total resistance, so like 33 ohms and 77 ohms, okay? And that's how that slider works. I'm taking a full resistor and I'm dividing it, okay, into fractions. So if I move it halfway, I created two resistors that are 50 ohms. If I moved it 3/4, this would be 75 ohms, and that would be 25 ohms. So what this switch is doing is it's taking that potential and it is dividing it. If it's 50-50, then I would have 12 volts, okay, and 12 volts, and 12 volts, okay. If it was three quarters of the way, all right, then I would have 16 volts and 8 volts over here. And that's how your potential divider works. There's many problems on page 224 of Tsokos for you to see how that slider system works, okay? So just remember, if I move that the further I move this slider to the right, the greater the voltage is going to be here. The more I move it to the left, the less the voltage is going to be.